Three letters matter here. CID. As in, if your CI/CD pipeline was pulling the Bitwarden CLI from NPM during the compromise window, your secrets may already be gone. Let's establish what actually happened, because the reporting on this is thinner than it should be for a credential manager getting hit on a package registry. The Bitwarden CLI is published to NPM under the scoped package name @bitwarden/CLI. At some point, attackers managed to publish a malicious version to that package on NPM. The payload was a credential stealer, meaning it was designed to exfiltrate sensitive data from whatever environment it ran in. Bitwarden has since removed the malicious version and published a clean one, but the window of exposure is the critical question here, and that window is not precisely documented in the public reporting. Bleeping Computer covered this, but their piece is largely based on what Bitwarden communicated, which means we're working from a vendor-curated account. Independent forensic detail is, at this point, unclear from the reporting. So let's talk about what the attack surface actually looks like, because this is not a story about Bitwarden the product being hacked. This is a story about NPM as an attack vector against a security-critical tool. The Bitwarden CLI is a command-line interface that lets you interact with your Bitwarden vault programmatically. Engineers use it to inject secrets into CI pipelines, to pull credentials at deploy time, to script vault operations. It's exactly the kind of tool that gets installed in automation contexts with elevated access and broad network reach. If you're running it in a GitHub Actions runner, a Jenkins agent, or a Kubernetes job, it probably has access to environment variables, mounted secrets, and outbound network. That's a very attractive target for a credential stealer. Now, how did attackers get a malicious package onto NPM under the legitimate scoped name? This is the part where I have to be honest. The exact mechanism is unclear from the reporting. There are a few standard playbooks for this. One is account takeover, compromising the NPM credentials of someone with publish rights to the package. Another is a dependency confusion or type-squatting variant, though that's less likely for a scoped package with an established publish history. A third possibility is a compromised CI pipeline on Bitwarden's own side that pushed a poison build. Which of these actually happened here? We don't know from what's been published. Bitwarden hasn't, as of this recording, released a detailed incident postmortem with a root cause. That's a problem, and we'll come back to it. What we do know is that NPM's model makes this kind of attack structurally easy. Anyone who has publish rights to a package can push a new version. If those credentials are phished, reused, or leaked, an attacker can push malicious code to millions of downstream consumers before anyone notices. NPM does have some mitigations: two-factor authentication for publishing, granular access tokens, package provenance via SigStore, but adoption of the stronger controls is inconsistent, and the registry doesn't block a publish just because it looks anomalous. The supply chain attack pattern here follows what we've seen in dozens of incidents going back to the event stream compromise in 2018. You target a package that has privileged access in its runtime context. You get code execution in environments where secrets live. You exfiltrate. The specific twist with Bitwarden CLI is that the tool is literally a credential manager interface, so the irony is pretty bleak. You're using a tool to protect secrets, and the tool becomes the vector for stealing them. Let's talk about the spread claim, because the original reporting mentions the payload was capable of spreading to other projects. This is an important technical detail that's frustratingly vague in the coverage. A credential stealer that spreads to other projects could mean a few things. It could mean the malicious package modified local NPM configuration or injected itself into post-install hooks in other packages in the same environment. It could mean it wrote malicious code into project files in the working directory. It could mean it exfiltrated credentials that could then be used to compromise other systems downstream. Without a technical breakdown of the payload, we can't say which of these is accurate. If the payload genuinely had self-propagating behavior that modified other packages on disk, that's significantly worse than a simple exfiltration script. But calling it capable of spreading, without that detail, is doing a lot of work for a pretty critical distinction. Unclear from the reporting. Here's what the operational impact looks like for a team using Bitwarden CLI in automation. First, any environment that ran npm install or npm sci and pulled the compromised version during the exposure window potentially executed malicious code. That means any secrets accessible in that environment variables, files on disk, network-accessible secret stores, should be considered compromised. Second, if the payload had persistence or lateral movement capability, the blast radius extends beyond that single runner or container. Third, because this is a credential manager, the secrets at risk aren't just deployment keys or API tokens. They could include master passwords, session tokens, or vault unlock keys that give access to everything else in the vault. The version question is critical and also underreported. Which specific versions of Bitwarden CLI were malicious? The reporting says a malicious version was uploaded, but doesn't clearly enumerate the version numbers. If you're auditing your exposure, you need to know exactly which versions to look for in your lock files, your Docker layer history, your NPM cache. If Bitwarden has published that list, check their security advisory directly. If they haven't, that's a gap in their incident communication. Speaking of incident communication, this is where I want to push back on how this is being handled. A credential manager getting a malicious package pushed to its primary distribution channel is a Tier 1 security incident. The appropriate response includes a detailed postmortem with a timeline, root cause, indicators of compromise, and specific remediation steps for affected users. What we have instead, based on available reporting, is a relatively brief acknowledgement and a clean version push. That may be adequate for a typical NPM package. It is not adequate for a security tool that sits in privileged positions across engineering infrastructure. If you're a Bitwarden Enterprise customer, you should be asking them directly for a full incident report, not waiting for a blog post. Let me also flag the broader context here, because this isn't an isolated event. The NPM ecosystem has had a genuinely bad run on supply chain security. We've seen malicious packages in the thousands over the past few years, some targeting specific organizations, some casting wide nets for credentials and environment data. The tooling to detect this is improving. Sockets, the security company, does behavioral analysis of NPM packages and catches a lot of malicious publishes before they spread. OpenSSF has the package analysis project. GitHub's dependency review action can flag known malicious versions in pull requests, but these controls only help if you've actually wired them into your pipeline. Most teams haven't. The practical thing to check right now: go look at your package lock. JSON files and your Docker build logs for any reference to @Bitwarden/CLI. If you find it, check the version against whatever Bitwarden ends up publishing as the compromised range. If you were pulling it without a pinned version, meaning you had a caret or tilde range specifier, you were automatically eligible to receive whatever the latest version was, including a malicious one. That's the fundamental problem with unpinned dependencies in CI environments that have access to secrets. And here's the real takeaway, the one that applies regardless of whether your team uses Bitwarden CLI specifically. Any tool that runs in your CI/CD environment with access to secrets should be treated as a security boundary. That means pinning exact versions, verifying checksums or provenance where the registry supports it, running with least privilege so a compromised tool can't access secrets it doesn't need, and having a process to detect when a dependency you're using gets flagged as malicious. Most teams treat CI tooling as low-risk infrastructure. This incident is a reminder that it's actually one of the highest risk surfaces you have, because it combines code execution, secret access, and network egress in a single place. If you're using Bitwarden CLI in automation, audit your version history now, rotate any secrets that were accessible in those environments, and don't wait for Bitwarden to tell you the all clear. Assume exposure during the window, act accordingly, and then ask Bitwarden for the postmortem they should be writing.